Hey, welcome. You know how it is. Every single year, it's the same old story. The sniffles, the coughs, just feeling run down. But what if there was a natural compound that could actually change how our bodies deal with the common cold? Today, we're going to dig into the science of something called beta-glucan and see what it might mean for our yearly battle with all those respiratory bugs. Okay, so here's our game plan. First up, we're going to look at the cold hard facts, the real impact of getting sick that we all kind of underestimate. Then we'll introduce our main player, beta-glucan. From there, we'll dive into the actual evidence from human trials before exploring a really fascinating new theory on how it might be working. And finally, we'll pull back and look at the big picture.
All right, let's start with the problem itself. We have this tendency to just brush off the common cold, right? We think it's just a minor annoyance. But when you look at the collective data, it tells a much, much bigger story.
I mean, we've all said it, oh, it's just a cold. But is it? When you take that one minor inconvenience and multiply it by an entire population, it suddenly blows up into this massive public health and economic issue. The scale of it is pretty wild.
Get a load of this number, 500 million. That's not a typo. According to a study from back in 2003, that's the estimated number of common colds, the non-flu kind, that happen in the United States every single year.
And you can absolutely put a price tag on that. We're talking about an economic hit of around $40 billion a year in the U.S. alone. And for each of us, every cold costs about 8.7 hours in lost work time. Since most adults get sick 2 to 5 times a year, well, you can see how fast that adds up.
Okay, so we've laid out this huge, often ignored problem. Now let's pivot and talk about a potential solution. It's a compound from nature that our immune system is actually built to recognize, one that might not just help us fight infections, but help us endure them with less damage. Let's meet beta-glucan.
So what is this stuff anyway? Well, in simple terms, beta-glucan is a type of complex sugar, a polysaccharide, that you find in the cell walls of things like yeast, mushrooms, and even oats. And because our bodies don't make it, our immune system is basically hardwired to see it as something foreign, which kicks off a response.
Now this is super important. Not all beta-glucans are created equal. The ones you get from grains like oats have a pretty simple, straight, linear structure. But the beta-glucans from yeast, they have this complex, branched structure. And researchers think this branching is the absolute key to its unique activity. It's this yeast-derived form that all the human trials we're about to talk about focused on.
All right, now for the part I'm sure you've been waiting for. What actually happens when people take it? Let's get into the evidence from the human trials.
But first, before we dive into the results, I have to stress something about these studies. The data we're looking at isn't just from anywhere. It's from randomized, double-blind, placebo-controlled trials. This is the gold standard in research for a reason. It's designed to strip out any bias and give us the most reliable answers possible.
So let's check out one of the headline findings. A 2012 study followed 162 people over 16 weeks. What they found was pretty amazing. The group taking the yeast beta-glucan reported 25% fewer colds compared to the group taking a placebo. A 25% drop, that's a really significant number. And get this, it's not just about getting sick less often. It's also about what happens when you do get sick. Data from 3 different trials show this really clearly. In one, the beta-glucan group missed 0 days of work or school. The placebo group, an average of 1.38 days. Another study found people had way fewer problems sleeping. And a third one, this one on marathon runners, found they missed way fewer workout days.
So if we're going to sum up all these human trials, the data is all pointing in the same direction. We're seeing fewer colds overall, and when people do get sick, the symptoms are milder, and it just messes with their daily life a whole lot less. And this isn't just self-reported. Both the participants and their doctors rated it as being more effective than the placebo.
Okay, so the data from people is pretty compelling, right? But it brings up a massive question. How? How is it actually working? To answer that, we have to go from the clinic to the lab and look at some fascinating new research.
And just to be totally 100% clear, we're making a really important shift here. We're moving away from what we see in people, and we're now looking at studies in mice that are designed specifically to figure out the biological how, the mechanisms behind the effects we just saw. So this is all about the how.
To really get this new theory, we got to think about 2 different ways our body can defend itself. First, there's host resistance. That's the all-out war. Attack the bug, kill the bug. But then, there's this other idea called disease tolerance.
That's about limiting the damage, the collateral damage, that the infection and our own immune system causes to our body. And a groundbreaking new paper suggests beta-glucan works mostly through this second path.
This quote from that study just nails it. They found that in mice with the flu, the beta-glucan didn't actually help them get rid of the virus any faster. Nope. Instead, it helped them survive by reducing the damage and inflammation in their lungs. It was helping them tolerate the disease. So how on earth does it do that? Well, the theory goes something like this. Think of beta-glucan as a long-term trainer for your immune system. It travels to the bone marrow, where it primes the stem cells that make your immune cells. This leads to the creation of a special type of immune cell, a regulatory neutrophil. Then, when an infection hits, these special forces travel to the lungs and release signals that basically tell the immune system to calm down, which prevents all that damaging inflammation.
Okay, let's zoom back out now and pull all of this together. After going through all this research, what are the big takeaways? What should we remember?
Here are the 4 really crucial points. First, the common cold is a way bigger deal than we give it credit for. Second, we have a really solid body of human clinical trials suggesting that this specific yeast beta-glucan can help us get sick less often and make it less severe when we do. Third, this isn't just about boosting your immune system to fight harder. And finally, that's because this new animal research points to a totally different strategy, disease tolerance, helping our bodies withstand the stress of an infection with less self-inflicted damage.
Which really leads us to this final, pretty thought-provoking question. We always think about immunity as a war, right? A battle between us and the bug. But what if the future of immune health is less about fighting harder and more about building a resilient system that can tolerate threats without destroying itself in the process? It's a fascinating new way to think about what it really means to stay healthy. Thanks for joining me.